This is an instructional video on how to perform an acid-base titration calculation. So our question is, a sample of hydrochloric acid is dissolved in water and an acid-base indicator is added. The sample requires 34.47 milliliters of 0.455 molar sodium hydroxide to reach the equivalence point. What is the mass of the hydrochloric acid? So like any stoichiometry question, our first step is to write the balanced chemical equation. Unfortunately, the equation is already balanced. The equation is NaOH plus HCl becomes NaCl plus H2O. And what we know is that we have 34.47 milliliters of NaOH, which is the same as 0.03447 liters of NaOH, as well, and we know that the concentration is 0.455 molar or mole per liter. So the reason we converted the milliliters into liters is because our our equation for moles is N equals CV, and C is mole per liter. So we need to know how many liters we have, which is 0.03447. So now we can just plug in our numbers that we know. So we know the concentration, which is 0.455, and we can multiply it by the volume, 0.03447 liters. And from that we can get the moles, which is, let's put on my calculator, so that gives us 0.01568,385. moles. Now, using our mole ratios, we can see that for every 1 mole of sodium hydroxide, we need 1 mole of hydrochloric acid. So therefore, if we have 0.01568,385 moles of sodium hydroxide, then we will have an equal amount of moles of hydrochloric acid. Okay, so now that we know the moles of hydrochloric acid, we can use our mass over molar mass equation to find the mass of the hydrochloric acid. So the equation is moles equals mass over molar mass. So we know our moles. We don't know our mass, that's what we're trying to look for. But we can find our molar mass using our periodic table. So the mass of one hydrogen atom is 1.01, and the mass of chlorine is 35.45. So our molar mass for HCl would be 36.46. Now, if we rearrange it, we will be left with mass equals 0.01568,385 times 36.46. So basically it's the moles times the molar mass. And we're left with, we already got that there, times 36.46. So our answer is 0.572 grams. So we've answered our question, as now we know the mass of the hydrochloric acid, and from this you can calculate other things like the percent mass and other values that you would like to know. So to recap, we started off by balancing the chemical equation, and then we wrote down what we know, and we converted our milliliters into liters, and then we found our moles using our equation N equals CV, and then we used our mole ratios to find the moles of our hydrochloric acid, and then we used our equation moles equals mass over molar mass to find the mass of the hydrochloric acid. And that is how you perform an acid-base titration calculation.